Welcome to Unit 5 Day 4 Notes, Factoring Binomials. A binomial is a polynomial that has two terms. Anytime you try to factor a binomial, you should look for a greatest common factor first. Then we need to check and see if the binomial is a difference of squares. What is a difference of squares? For a binomial to be a difference of squares, it must meet the criteria below. 1, it must be a difference, meaning that there must be a subtraction sign between the two terms, and 2, both terms must be perfect squares. If both criteria above are met, then we can apply the following formula. So I have a difference of squares where two terms are separated by a minus sign and the two terms are perfect squares. So if both criteria are met, then we can factor this out and get a plus b times the quantity of a minus b. Now, how do we know if something is a perfect square? Well, here is a table of perfect squares. These things that I highlighted are perfect squares because if you look at a number and you take that number and multiply by itself, then the result is a perfect square. So here's an example. I look at this 1. 1 times 1 is going to give you a perfect square, which is 1. Here's 2. 2 times 2 gives you a perfect square, which is 4. Here's 7. 7 times 7 is going to give you 49, a perfect square. Here's 12. 12 times 12 is going to give you a perfect square, which is 144. Now, the opposite of squaring something is square rooting. So if I were to look at this perfect square, this 81, if I were to take the square root of 81, then that is going to give you 9. And this is something important to know because we need to take the square root of things, right? Now, if I were to take the square root of 144, then that's going to be 12. For a variable to be a perfect square, it must have an even exponent. So this is also important too. So if we have x to the second, x to the fourth, x to the sixth, x to the eighth, etc., those are examples of perfect squares. Now, if you were to do the inverse, meaning you're taking the square root, if you were to take the square root of x to the second power, you're going to get x to the first power. If you were to take the square root of x to the fourth power, you're going to get x to the second power. If you were to take the square root of x to the sixth, you're going to get x to the third. If you were to take the square root of x to the eighth, that's going to be x to the fourth. So hopefully by now you are able to recognize what's going on. So what's the pattern here? Well, basically you look at the even exponent and then divide by 2. So the square root of x to the second power. If you look at the power of 2, you divide that by 2, and guess what? You get 1. If you get the square root of x to the 6, you look at 6, divide that by 2, and you get 3, and then you know the drill when you have the square root of x to the 8th, that's going to give you x to the 4th. So, hopefully we have an understanding of what we need in order to factor, okay? So, we're going to go ahead and look at number 1 here. We have x squared minus 25. Now, one thing that we need to do is check to see if it meets both of the criteria above. 1, are these two terms separated by a minus sign? Yes, so step 1 complete. Step 2, are these two terms perfect squares? Well, x squared, that's a perfect square, so yes. Here's 25. Now, is 25 a perfect square? Well, it says on our table of perfect squares, right? So 25 is indeed a perfect square. So what we can do now is apply this formula. So remember, it's a squared minus b squared, which is equal to a plus b times the quantity of a minus b. So you have to take the square root of each perfect square. So if I take the square root of a squared, you're going to get a. If you take the square root of b squared, then you're going to get b. So that's important to know as well. So one thing that we need to do, since number 1 meets both of the criteria, we need to take the square root of each perfect square. So the square root of x to the second power is going to give you x to the first power, or x, right? Remember, if we take the square root of a variable raised to an even power, we take that power and divide that by 2, so we get x to the first, or just x. And then we need to take the square root of 25, and the square root of 25 is 5. So let's go ahead and build our answer. Note that since this is the first term, this is a squared, right? So therefore, this is a. And 25 is b squared, therefore 5 is b. So a goes first, so it's going to be x. Then we have a plus sign, plus b, which is 5. And then for the other, that would be x minus, because this other one has a minus sign, and then our b value is 5. So x plus 5 times the quantity of x minus 5. Number 2, 4x squared minus 1. Yes, these two terms are separated by a minus sign, and 4x squared and 1 are those perfect squares. Well, 4 is a perfect square, and it's multiplied by a perfect square. And over here, 1 is a perfect square, so yes, these two terms are perfect squares. Now what we need to do is take the square root of each term. So the square root of 4x squared, what's the square root of 4? Well, that's 2. What's the square root of x to the second? Well, that's just x. And then we need to take the square root of 1, which is 1. So this is our a, and this is our b. Therefore, we have 2x plus 1 times the quantity of 2x minus 1. Number 3, we have 100a to the second power minus 81b to the second power. So these two terms are separated by a minus sign. And 100 is a perfect square times a squared, which is also a perfect square. 81 is a perfect square, and b squared is a perfect square. So yes, we can factor by using the difference of two squares. So let's take the square root of 100 a to the second power. The square root of 100 is 10, and the square root of a to the second power is just a. And then the square root of 81b to the second, the square root of 81 is 9, and the square root of b to the second is b. So here's my a, and here's my b. So we have 10a plus 9b, and we have 10a minus 9b. So again, one's plus, one's minus. So our answer is 10a plus 9b times the quantity of 10a minus 9b. Number 4, we have 4x to the second plus 1. Alright, so here's the problem with this example. This has a plus sign, it's not a minus sign. But we can appreciate the fact that these two terms are indeed perfect squares. However, we cannot factor this because this is not a minus sign. So we have to write prime as our answer because we cannot factor this. Now moving on, sometimes you may have to take out a greatest common factor before you can factor something as a difference of squares, or you might have a difference of squares left to factor after you factor by grouping. So we're going to incorporate some of the factoring techniques that we talked about thus far. So let's look at number 5, 2x to the second power minus 98. Now one thing that I like to do first is see if I can take out the greatest common factor between the terms involved. So we have 2x squared minus 98. What is the greatest common factor between those two terms? Well, the largest number that goes into those two terms is 2. So the greatest common factor is 2. Now hopefully you remember that we format it like this. The GCF times the remainder, right? So in this case, it's 2, which is my GCF, times x squared minus 49. Now we're not done, because if we look inside of the parentheses, that x squared minus 49 is indeed a difference of squares. So I'll make a quick note here and say that this is a difference of 2 squares, dots. Now, how we're going to do this is we're going to take the square root of x to the second power, which is x, and the square root of 49, which is 7. So we know that this is my a and my b. Okay, so here we go. We took out a 2, so 2 should be part of the answer. And then we'll create our parentheses. So it's going to be x plus 7 and then x minus 7. So our answer is 2 times the quantity of x plus 7 times the quantity of x minus 7. Number 6, we have x squared minus 25x. Remember, we like to take out the GCF first. So in this case, the GCF between x squared and 25x is just x. So we have x times quantity of x minus 25. Now, let's take a look at the remainder. Yes, we have a minus sign. However, this 25 is the only perfect square of the two, because this is just an x. If this was an x to the second power, then yes, I can keep going by factoring. So our answer is x times the quantity of x minus 25, because there's nothing else I can do. Okay, so I'll make a quick note here, not a difference of 2 squares. Number 7, 50x to the second minus 2. So here we're going to take out the GCF, and the GCF between 50x to the second minus 2 is 2. So 2 times the quantity of 25x to the second minus 1. And yes, the remainder is a difference of 2 squares. So we're going to take the square root of 25x to the second, which is going to be 5x, and we're going to take the square root of 1, which is just 1. So note that 5x is our a and 1 is our b. So don't forget, when we build our answer, we need to have 2, the GCF, right, to be part of our answer. And then we'll write our parentheses here. So 2 times the quantity of 5x plus 1 times the quantity of 5x minus 1. And that's our answer. Number 8, we have 3x to the second plus 27. The GCF between these two terms is 3. So 3 times the quantity of x to the second plus 9. Now, if we look, this has a plus sign. It's not a minus sign. So we're basically done, because this is prime. So I cannot factor that. So therefore, we're just going to write 3 times the quantity of x squared plus 9. Number 9, we have x to the second times the quantity of x minus 4 minus 4 times the quantity of x minus 4. So remember, we're going to take out the GCF, which in this case, if we remember from the last lesson, we have 2 of the same polynomials, that x minus 4. So we're going to factor that out. So remember, GCF first, then the remainder. So it's x minus 4 times what's left over, which is x squared minus 4. Now look at the remainder. We have x squared minus 4. Yes, these two terms are separated by a minus sign. And yes, x squared is a perfect square and 4 is a perfect square. So we're going to take the square root of each to figure out our a and b values. So the square root of x to the second is x, and the square root of 4 is 2. This is our a, this is our b. So to write our answer, we need to remember that x minus 4 is the GCF. It should be part of the answer. And then we'll create our two sets of parentheses. And therefore, we should have x plus 2 here and x minus 2 there. So x minus 4 times the quantity of x plus 2 times the quantity of x minus 2 is our answer. And then lastly, we have n cubed plus n to the second times m minus n times m squared minus m to the third. Okay, so one thing that we need to do when we have 1, 2, 3, 4 terms, we group them. So meaning we group the first two terms and we group the last two terms. So we're going to take the GCF of the first group and then take the GCF of the second group. So what's the GCF of the first group? Well, if we look at these two terms, they both have an n. And the smallest exponent between the two is 2. So the GCF is n to the second. Over here, what's the GCF? Well, they carry a negative sign, so we need to make sure we factor out the negative. So the GCF should have a negative. And then these two terms carry an m. So we're going to factor out an m, but since there is a 2 and a 3 in terms of exponents, what I need to put here is the smallest of the two, which is 2, right? The exponent of 2. That's the GCF between these two terms. All right, so then we're going to go ahead and factor. We're going to factor the stuff that's underlined in green, and then we'll factor the stuff underlined in pink. Okay, so n squared times n plus m. And then we'll write our GCF here, which is negative m squared. So let me go ahead and use a different color. So negative m to the second power. And then you're going to get n plus m. And we're going to factor again because there's an n plus m here and an n plus m there. So n plus m times my leftovers, which are n squared minus m squared. And then look over here. We have a difference of 2 squares because these two terms are separated by a minus sign, and this is a variable being squared, and this variable is also being squared. And remember, a variable that has an even exponent is considered a perfect square. So we'll take the square root of n squared, which is n, and the square root of m squared, which is m. Here's my a, here's my b. So our answer should be n plus m times the quantity of n plus m times the quantity of n minus m. And that is our answer.